Yeah, I can give you a little background on some additional CLIPS capabilities that we're looking at. The CLIPS flights are commercial.
Sugerencia donde ponemos siempre platos especiales, así que cuando os queráis, bienvenidos.
Ahora, ¿qué tal? ¿Todo bien? Sí, se escucha bien, ¿no? Ya está.
Or M-Solo. M-Solo will identify low molecular weight volatiles. It can be installed to either measure the lunar exosphere or even things like spacecraft outgassing and contamination.
Sugerencia donde ponemos siempre platos especiales, así que cuando os queráis, bienvenidos.
Ahora, ¿qué tal? ¿Todo bien? Sí, se escucha bien, ¿no? Ya está.
Be mined from the moon and used by our future explorers. They also help map surface temperature changes at the landing site. So this is the precursor drill, and it will fly with Viper, which will fly. It is a precursor to the Trident drill that's going to fly with M-Solo on Viper. So this is going to give us an example of how exactly to use the more enabled Viper mission when we get it there. So we do have a series of activities and payloads that are already set up to help us start measuring this and understand more about the environment and the vault.
Great, thank you. Next question is Marcia Dunn from AP. Oh, sorry. Yes, Marcia Dunn from AP.
Yes, hi. Can you hear me?
Yes.
Hello? Yes. Yes, this is for the lead author, Ms. Hannibal. Could you tell me, please, how much, over how much area of the moon did you detect these molecules, the water molecules? If you could give some sense of how vast an area, how small an area, and how many molecules are we actually talking about in the thousands, millions? I'm just trying to get a handle on how big and how much. Thank you.
Yeah, so the Clavius crater is the largest crater observed from the Earth, but it's not that big. When we looked at the moon, our observations extended from about a 50-degree latitude down to about 75 degrees in latitude on the moon. So we only covered a few degrees on the moon. What also, the abundances that we measured are only 100 to 400 ppm of water, which is not a lot. Like I said, these water molecules are not interacting with each other. They are individual molecules incorporated into these glass beads, so they're not in a form of ice or liquid.
Thank you. Next question. We have David Curley from the Discovery Channel.
Thanks for taking the question. You kind of touched on it there. I mean, this is an amazing discovery, but how much is there? Will it matter? Will it provide for astronauts if we need to mine it? Thank you.
Casey, I think maybe you could reiterate the amount of water.
Yeah, so the amount of water is roughly equivalent to a 12-ounce bottle of water within a cubic meter of lunar soil. But this, instead of being at a volume, this is spread across the surface of the moon. Whether or not it's usable for mining, I will turn over to Jacob.
Yeah, thanks, Casey. And this is, this is the core part to the question, right? And I think several of us hinted at this, is that we really need to understand more about the water that's present. So we need to understand what form it's in. We need to understand how much of it there is. And this complement of approaches, of measurements that we can make, some of them look at just at the surface. Some can look deeper below the surface. Some see water in different forms than in other forms. We need to gain that broad picture of what the resource stock really is at the South Polar region. We also need to understand how we can not only approach it as a resource, but how we can also use it as a science resource, because that ice also carries with it much information about evolution of the solar system, evolution of the sun, evolution of the moon-Earth system. So, it's hard to answer the question straight up, is this discovery going to provide us with enough water to do anything specific? It's part of a process in moving forward and understanding volatiles and volatile cycles on the moon. And this is an important discovery because now we know that that water does exist outside of some of these places in these dark craters that are really hard to get into and really hard to operate in. So this might be an avenue for us to get to water a little bit easier.
Thank you. Next, I believe we have Joey Roulette from Reuters.
Hey, question for Paul and Jacob. Kind of similar to what was asked before, but what will it take to know whether the water molecules can be turned into usable resources to support the Artemis program, like drinkable water, ingredients for rocket fuel, etc.? Do you think we'll know this from more remote observations, or will we have to rely on future robots or probes on the ground on the moon? Thanks.
I can give my my first shot at answering that question. We already listed off a handful of additional payloads that are planned to go to the lunar surface. I think it's critical that we combine remote observation, which can give us the broad context. So, observations from Sophia, observations that look more broadly at the moon can tell us regionally where we see those signatures. But then we need to also get on the ground and sample. So we have, as I mentioned, the Viper mission is heading that way. And, I hope that you can see that this is kind of an iterative approach. So, for instance, we're sending the Prime 1 drill to help us understand better how to approach it when we get Viper there. That's a more capable vehicle. So, answering the question exactly when we'll know is difficult. What I can say is that from a in situ resource utilization perspective, we have multiple approaches to extracting the water, multiple activities that are underway. And as we learn more, we'll know better which of those to develop further so that we can follow that approach. And it may be that there's multiple approaches because the water may be in different forms in different places. It may be more accessible. We also have to learn just simply going up to the water. Are we going to be disruptive to it to the point that we then can't use it? So, each one of these lessons helps us learn better how to query the lunar environment, the lunar surface on our next step moving forward.
Thank you. Next, we have Kenneth Chang from the New York Times. Kenneth? Hello, Kenneth. Are you on? Okay, before we go back to Kenneth, let's go ahead and take some Ask NASA questions. If you would like to ask a question using Twitter, please use the hashtag AskNASA. So we have a question from Liam Parker asking, what volume of water is found and does it suggest life may have been present on the moon previously? Sarah, can you talk about that?
Sure. So we covered a little bit about how much water is there. It's not a lot. And it's also water by itself is really not enough. There are other ingredients necessary for life. And the moon is frankly a really harsh place. The radiation environment, the lack of an atmosphere. There are lots of reasons we can talk about that where life is just not a thing that we think could have ever been possible.
Thank you. Let's try to jump back to the Q&A. Kenneth, are you available?
Yes, can you hear me now?
Yes.
Sorry about that. I just wanted to clarify a few things. In 2009, there was data from Chandrayaan-1 about water in the sunlit areas. Is this a confirmation of that, confirming that it's water and not hydroxyl, but otherwise similar? And was there a confirmation of water in the deep craters from the L-Cross, or is there also that ambiguity between H2O and hydroxyl?
Hi, this is Casey. So I can take the first part of that. The observations from 2009 with M-Cube on the lunar surface were of the 3-micron band, which could not distinguish between hydroxyl and water molecules. What our detection today on the sunlit moon is saying is that at least part of what M-Cube detected is in the form of molecular water. Maybe somebody else can take the L-Cross part.
Sure. Let me jump in. L-Cross did in fact find water, but that was of course looking in a permanently shadowed region. So the difference here is that we're now seeing it in sunlight as well.
Great, thank you. Next, we have Christopher Coquions from Sky News Canada.
Yes, can you hear me okay?
Yes.
Okay, and it's Coquino, so it's an odd name. No worries. First, congratulations to the team. And then a question about the map, the water map of Clavius. And did you see any evidence of these molecules over time? In other words, these apparent glass beads that are containing these stray water molecules, are they breaking down? Are they moving at all due to solar wind or micrometeorite impacts? So was this, do you see a process? Is the map dynamic at all, or is that something to look for in future missions?
This is Casey. Yeah, that is definitely something that we are going to be looking for moving forward with continuing observations with SOFIA. With the current data, it's just a snapshot in time of one location at one time on the moon. So we need, in order to understand the mobility of water and if it's moving and how it's really stored, we need more observations of different lunar phases to really be able to get at that mobility problem of water.
Great, thank you. Next, we have Leo Enright from Irish TV.
Thanks very much. I'm wondering about the source of this water. You mentioned one possibility as glass beads on the surface being impacted by the solar wind. Now, I'm afraid I'm showing my age with this question, but I was actually in the science support room in the Mission Control Center during 2017 when they were at Shorty Crater. And I will never forget the scenes in that room when they found orange soil, because everybody in the room believed that that meant water, and they were devastated, many of them, though they're scientists, when they discovered, well, maybe it wasn't. I'm wondering, could those be exactly the beads that you're talking about?
Hi, this is Casey. So those are actually different kinds of beads. Those are volcanic beads that were erupted during a volcanic process on the moon. The glass beads that we're talking about are little beads that form when a micrometeorite impacts the moon and melts part of the lunar surface. It melts it and could either deliver the water or form water from pre-existing hydroxyl, which then cools to form a little, what we are calling little glass beads. So there's the ones that they found on Apollo and the ones that we're talking about here are different beads. We do think that the Apollo glass fleet, we can do observations of the Apollo 17 site to possibly detect water at that location with SOFIA.
And if I may cheat and ask a follow-up, I'm particularly interested in the instrument that you were using. It's my understanding that it was designed and built. It's my understanding that it was designed and built by the Andor Company in Belfast in Northern Ireland. Is that correct?
I'm going to pass this one on to Nassim.
Are you talking about the instrument that they just...
Yes, the CCD device. I understood it was built by Andor.
Well, I will have to get that specific information from the project, but the instrument itself was made in the U.S. by U.S. institutions.
Okay.
Thank you. We will take another question from the phone lines and then go back to Ask NASA questions and then jump back to the phone lines. Let's start with Jim Siegel from NASA Tech. Jim, can you hear us? Jim, can you hear us? Okay, while we try to get through with Jim, let's go ahead and try to answer a question from Ask NASA. Based on the data for the near side of the moon, have we any assumptions for the far side? Find the same abundance and the same process? This question?
Yeah, so we believe that on the far side of the moon, the abundances are probably going to be very similar to what we see on. So we believe that on the far side of the moon, the abundances are probably going to be very similar to what we see on the near side of the moon. We obviously be able to tell if there's locations that may be different, though.
Great. This one's for Paul Hertz. Will James Webb Space Telescope be useful for confirming and enhancing water detection on the moon?
Yeah, thanks, Felicia. Well, it is true that Webb has instruments which cover this 6-micron wavelength. However, Webb cannot look in the direction of the Earth, Moon, or Sun. Its tennis court-size sun shield blocks all light and heat in those directions, which is how Webb is its very, very cold telescope surface. So, no, it cannot look at the moon.
Okay, great. Here's a question for Sarah from Rev D. With finding water on the surface of the moon, do we expect to find more water at deeper depths of the moon?
So that's a great question and one that we need more data on, right? So this instrument can only see the very top surface of the moon. But if we assume that these are in, these glass beads we've been talking about, right, they'll get mixed in deeper and deeper into the soil over time, right, as you get more impacts coming in and create new ones. So they'll get buried down to depths of